My name is Alexey Soshin. I'm a contributor to the Exposed framework, and a few months ago, I released a video course about that framework. As you can guess, I'm a big fan. As I was working on the course, I discovered quite a few of the lesser-known features of the Exposed framework, which I'd like to share with you today. Disclaimer, I don't work for JetBrains. I'm not the maintainer of the Exposed framework. I'm simply a contributor. So if you hear me saying we during my talk, I mean the Exposed framework community. Some examples today will be from GitHub issues, or from Stack Overflow, or from things I discovered as I was working on my course. The title of my talk, 7 plus minus 2, refers to the number of things we can hold in our short-term memory. There are a couple of reasons I picked that title for my talk. First, I didn't want to commit to a specific number of topics, so this title gives me some space to maneuver. And second reason is that I know, as a rule, that if I try to present you more than 9, you'll probably forget some of them. Before we start diving into the different capabilities of the Exposed framework, I wanted to spend some time looking at the data model I'll be using. So when I start demonstrating different ways to map this data and interact with it, you'll already have that model in your head. So we'll have 3 tables: users, groups, and connection table members. A group can have multiple users, otherwise it's not a group, and a user can be in multiple groups. Of course, those tables can have more columns, but I tried to keep it as simple as possible. Now, try to keep that model in your head as I go through the examples, and I'll show that diagram a couple more times as I talk through them as well. Now, in order to understand the ideas behind the Exposed framework, we first need to discuss what are the alternatives. So I was thinking of comparing how would you interact with that model using another framework, such as Hibernate. So let's begin first with a quick show of hands. How many of you are currently using Hibernate or another form of JPA, such as Spring Data in production? 4, 6, okay, around 15. And how many of you are maybe using Exposed in production? Okay, that's great, actually great numbers. Thank you very much for that. This helps me understand how much time to spend on discussing different Exposed framework features and its syntax. Also helps me identify the Android developers and those that are just waiting for the coffee after my talk. Please note, I don't intend to criticize JPA or Hibernate in any way. I just want to compare different approaches to working with a relational database. Before discovering the Exposed framework, I would use JPA annotations to interact with the database. So let's see how it works. The examples are taken from the official Spring GitHub repository. And here we have a method that finds all the users that have a certain first name. It uses annotation on an interface and a specialized language called JPQL to specify the data to be retrieved at runtime. In the second example, we delete all users that have a certain last name. Here we use some conventions instead. We prefix the method name with an action word, such as remove, and we specify the columns we use in the method name. In both instances, there is no support available from the language itself. Those are just strings. You may get some support from your IDE. It depends on how smart your IDE is. But you still need to remember most of those conventions. If you work on a single project written in a single language, that's not a problem. But if you switch between projects, languages, and frameworks, as many of us do, the need to remember all those conventions becomes more and more cumbersome. During the development of Kotlin, JetBrains aimed to design a language that would be ideal for developing domain-specific languages, or DSLs. And they tested the abilities of their language using the Exposed framework. Interesting fact, some of you may not know, many of the commits to the Exposed library were made by JetBrains' CEO at the time, as he tested the limits of the new language his company was creating, and I find it super impressive. Instead of using annotations or conventions, as we've seen before, Exposed library provides you with two syntaxes. So we have the SQL DSL and we have DAO API. Here's an example how the previous two queries would look with SQL DSL. Great thing about DSLs in typed languages is that your IDE can support you. By using a DSL, you get contextual autocompletion and type safety of your SQL queries. Those aren't just strings anymore. Those are language constructs that we can work with. As I said, the Exposed framework also offers a DAO API for those who prefer working with objects instead of constructing queries. In this approach, methods are invoked on the entity instead of the table object. If my table and the object that represents it is called users, for example, in plural, the entity will be in singular, in this case, user. So, for example, instead of using select on a table, you would use find on your entity. Likewise, instead of composing a delete query, the DAO API allows to simply call the delete method on each object. So here we can iterate through the collection of objects, and each time we just can call delete, and it will delete the object from the database. The choice between using the SQL DSL and the DAO API is largely a matter of preference. While the DAO API is more straightforward, the SQL DSL is more robust. So there are things that you can do in SQL DSL which you won't be able to do with DAO API. It's important to know there are two syntaxes because some of the examples will be related to SQL DSL, some will be related to DAO DSL, and some will be mixing both. So let's start with our first topic, supporting many-to-many relationships. Going back to our data model, we have three tables, groups, users, and we have that members table that connects both. And now what developers usually want to do is something like that. You find a group, for example, and then get a collection of all its users. Or you maybe find a user and you get all their groups. It's a very useful feature, very ergonomic. Many frameworks support this, so people also expect that from Exposed. So let's see how we can express that idea with Exposed. First, let's look at the connection table that connects users to groups. This is an example of a SQL DSL syntax that describes a table in Exposed. You can see that it's a UUID table, meaning that its primary key is of UUID type. And it has references to two other tables, users and groups. We can define cascading constraints, so if a user or a group is deleted, the membership is deleted as well, and that doesn't pollute our database. And we also can have additional columns. We aren't limited to just 2 columns in a connection table, so we have we can have something like the created at column. Now let's look at the users entity. Here we use the DAO syntax. You can see that instead of tables, we talk about entities now. If the user entity, in the user entity, we define that we will retrieve groups via the members table. So that's something, some struggle to find in the documentation. We have that via function, and that's what defines the many-to-many relationship. So that's how you would define it. We specify that the source is the user, and the target are the groups that the user belongs to. Now let's take a look at the group entity, the other part, and concentrate on the definition on the last line. Here we specify again that we will retrieve users via the members table. But you can see that we actually don't have to specify the columns. Exposed framework can try and figure out how to use the connection table from the previous definitions that we've seen. And this is much simpler syntax to use. Another thing I wanted to show you while we are looking at that example anyway is how to define the one-to-many relationship in Exposed. So on the highlighted line, we say that a group can have only one owner, and the entity type of that owner is also user. So here we use reference on to define the one-to-many relationship. There are also other types of relationship Exposed supports, like many-to-one and back references. But I'll stop here because there are other topics you may not know about that I'd like to discuss. Just remember, autocompletion is your friend when you use Exposed. If you're not sure how to define a relationship you want, just use autocompletion and you'll see all the available options. You don't need to remember keywords or annotations or anything like that. Next, let's talk about dates and history. When we work with database tables, one of the most common data types are various dates and timestamps. Here's, for example, we have a created at column indicating when that user was first created. But this simple code won't compile unless you add another library to your project, which is quite strange. And you have 3 libraries to choose from. So let's explore why this is the case and which library is the best choice for that. First of all, the reason that Exposed doesn't have a built-in support for dates is that it was developed with Java 7 in mind. And Java 7 didn't provide good support for dates. So Exposed developers used the JODA-time library for representing dates in their project at first. However, when Java 8 was released, it came with a better support for dates. So Exposed added a second library that is called Java-time. Later on, Kotlin added its own datetime library for Kotlin multi-platform. And Exposed added support for Kotlin datetime library as well. As a result, there are now 3 date libraries to choose from. As a guideline, if you are working on a pure Kotlin project, you should use Kotlin datetime. If you have a mixed Java and Kotlin project, use Java-time. And JODA-time should only be used for legacy projects that are already using it somehow. Quick raise of hands, please. Anyone still using JODA in their projects? Anyone? Yeah? Okay. Still a few, great. And anyone is working on a mixed Java and Kotlin project? Not only pure Kotlin? Okay, quite a few people. Interesting. Thank you. I was wondering if maybe everyone already works on just pure Kotlin projects, so it's not so interesting. Well, next, let's talk about logging queries. It's quite easy to write even complex queries using SQL DSL. You have the type safety and auto-completion that I already mentioned. But sometimes you may be curious what the actual query looks like in plain SQL. So for those that didn't work with Exposed before, a slight detour that I need to make. Every interaction with the database in Exposed is wrapped in a transaction block. So you have that transaction. And then you can also configure that block. One way to configure it is by adding a logger to the transaction. So here we add a standard logger that will print all the SQL queries to the standard output. That's all well documented, easy to find. After you set up the logger in the transaction block, each query you run will be printed to the console just like this. Now, sometimes you'll see that there are a couple of issues with this approach. First, it prints all the queries within the transaction block, and you may be having, maybe you have a lot of queries and you just want to focus on one. So that logger doesn't let you debug a particular query. And the second issue is that it will print only queries that were executed. So if you have something like an if-else in your code, where you execute two different queries depending on the parameters, only one of those queries will be printed, the one that is executed. What do you do if you want to see what the other query looks like, which may be more complicated? You can set up parameters in the debugger, but there is a better way. So another way to inspect just a single query in Exposed that you may not know about is you can invoke a prepare SQL method on the query. And it will return the query as a string. This is useful if you want to run this query yourself. For example, you want to debug it, or you want to do an explain plan on that query. However, there is a subtle difference between this and using a logger. Prepare SQL method won't execute the query at all. It will return the SQL, but it won't run it. That means it will print your query even if it has columns that don't exist in the database, for example. Also, do you see that question mark? That's because parameters aren't actually assigned at that point. With logger, you'll see the actual parameters that were assigned, but here there is no assignment, so you won't see them. So prepare SQL is useful when you try to debug or optimize your queries, but don't use it in production. The next feature is something that is rather well documented in my opinion, but we still receive many questions about it, so I decided to cover it anyway. Coroutines and suspending functions are one of Kotlin's killer features. They allow you to be efficient with I/O, as you can run thousands of coroutines concurrently. And for these reasons, many Kotlin functions are already suspending functions. However, you cannot call suspending function from an exposed transaction block, as that block is not a suspending function itself. So let's look at an example. Here we have a simple suspending function that waits 10 milliseconds and doesn't return anything. If we try to call it from a transaction, we get a compilation error, because suspending functions should be called only from a coroutine or another suspending function. Does that mean that Exposed can't work with coroutines? Well, not really. To use suspending functions in Exposed transactions, you can use the new suspending transaction block. This function is suspending, which means you can call other suspending functions from it. That's the easy part. Now, let's complicate it a bit. You can nest suspending transactions using the suspended transaction function. This allows you to have finer control over your transactions, so you can open an inner transaction inside another transaction. If any part of the transaction fails, everything will be rolled back, just like with the regular transactions. One important thing to note is that if you use new suspended transaction within another new suspended transaction, it will create an independent transaction. This means that if the outer transaction fails, the inner transaction won't necessarily be rolled back. This can be desired in some cases, but not in others. Therefore, it's important to be mindful of this behavior and choose the appropriate strategy accordingly. To understand what that means, let's look at the following code. Here, we create a user for John, then we open a suspended transaction and create another user for Mary. Then we roll back the outer transaction and we check how many users we have in our database. And we have 0 users, since both the inner and the outer transactions are rolled back, as I said before. Let's now move the rollback into the inner suspending transaction and see what happens next. Who says it's different behavior? Who says it's the same? Okay, a lot of people need coffee. So it's the same behavior. We still have 0 users. The suspended transaction reuses the transaction that was already open. So when you roll back everything. Now we'll use the new suspended transaction and try to roll back the inner transaction. Let's see what happens. The data from the inner transaction is rolled back, but the outer transaction is not affected. You can see that John still exists in the database, but not Mary. And finally, let's move the rollback outside of the transaction and see what happens. Now, only Mary is still in the database, but John was rolled back. Bottom line, if you need to work with suspending functions, you can use new suspended transaction block instead of a regular transaction block. But you probably don't want to nest one new suspending transaction inside another, unless you really understand the consequences of that decision. Next, let's talk about expressions a bit. Working with expressions instead of strings makes Exposed type-safe. But it's not always straightforward, and I'll show you an example in a minute. So here we have an SQL query that someone tried to rewrite using Exposed. In the users table, we have a status column, and one of the statuses indicates that a user has been banned. The query counts the number of users that have not been banned. The way we do that is, if the column contains the status banned, we map it to null. If it contains any other status, we map it to 1. And the count function ignores null values. That's why the calculation will be correct. Now, some SQL experts here in the room may suggest better ways to write that query without using nulls. But for this example, let's assume that the person who wrote the query wanted to keep that logic for some reason. Now, let's try to write this query with exposed. So at the bottom, we still have the query, and at the top, we have the exposed code. For those that don't know, slice function is just exposed way of specifying which columns you want to query. Otherwise, it will query like basically a star. And we use the case builder to represent the case expression from the original query. As you can see, this is pretty similar to the SQL query, and you get auto-completion, so it isn't that hard to write. The problem we have here is that you cannot pass Kotlin's null to the when, and you also can't pass Kotlin's integer to the else. This simply won't compile. So the reason we can't simply use integers is that we're building an SQL expression here. First, we need to make an expression out of that constant. The way we do that in Exposed is by using int literal function. There are also other literal functions available if you need Boolean constants or other constants, for example. And that will solve one compilation issue. So we now can pass constants without problems to our expression, but we still have the problem with not being able to pass the null value to the when expression. The way the second problem can be solved is by using a null op exposed provides. It is an expression, and the value it returns is SQL null. Now, notice that this null expression has a type, and its type is int, which is very interesting. It's null, but it has a type. This is because exposed is more strongly typed than a regular SQL sometimes. In SQL, you can return a string from where and an int from somewhere else. And what will happen? Probably a runtime error. Exposed forces you to be more mindful with your types. That means that if your when returns an int, your else also returns an int, or vice versa. So we need to specify the type of the null, and its type here is integer. Now, if we could slightly modify the query and move the null op to the else case, move the null to the else case, Kotlin generic type inference would come into play, and we wouldn't need to explicitly specify the type of the null value anymore. Notice that we are now saying that if the status is not banned, then we return 1, otherwise we return null. And the null type is now inferred. So we rewritten, if we could rewrite that query, then our code would be a bit simpler. But as I said, rewriting queries is not always possible. Maybe you don't have tests, maybe you work on a legacy system. So, for example, in this case, we may have shortened our code a bit, but we also probably introduced a performance issue. So be careful when you try to rewrite your queries too much. All I want you to remember is that if you need to return null as part of your SQL query, whether you're doing something like a case or you're doing something like a union, there is a support for that in Exposed, so you can build those queries in Exposed. As I mentioned before, Exposed supports two syntaxes, the SQL DSL syntax and the DAO syntax. Sometimes you have a complex query that can only be written using a SQL DSL syntax. But then your application mostly works with DAO entities. So how would you translate between query results and the entities? You may try the following. Map through the results of the query. So query supports different higher order functions, for example, map. And then you can try to create an entity for each of the results manually. This will compile, but it will crash at runtime. So don't do it. The reason this code will crash is that those entities are detached from the framework. Exposed doesn't know what to do with them. They represent a row that exists in a database, but not in the entity cache. And Exposed will simply throw an exception if it encounters such an entity. Of course, there is a better way to map rows to entities, which I want to show you next. Exposed provides a convenient method called repRow for mapping a single row to a DAO entity. This eliminates the need for manual mapping and will also synchronize the entity caches. You just get the row from the database, and then your entity can map that row by itself. In fact, you don't even need to map row by yourself. You don't need that iteration. Exposed can do that for you as well. There is another function available on an entity called repRows, in plural, and it simply takes the query and attempts to map the query results to a collection of entities. So if you need to map your queries to objects, just use one of those functions. Next, let's talk about event listeners. As your system grows, there eventually comes a time when someone asks you to implement auditing. It's basically unavoidable. As an example, here we have a flow of events that, where we first create a user, then we update their status, and then we delete that user from the database. And we now need to somehow track and log all those changes. For that, Exposed provides us with entity hooks. In your transaction, you can subscribe to entity changes. In this case, I'm logging all the changes to the console, no matter what entity was touched and what type of change it was. In your case, you may want to log only some changes on some entities. For example, if you only want to track changes about users or only want to track changes about financial data. And the output will look something like this. So we now know that a user was created, then it was updated, and finally it was deleted, simply because we created a hook that is triggered every time something happens with an entity. If at some point you want to stop those events from flowing, you can also unsubscribe. In order to do that, you need to save the handle that subscribe returns. And then you can pass that handle to the unsubscribe method, and this will remove the listener. So in this case, if I call unsubscribe before I invoke the delete method, I won't see the remove line in my output anymore. And that basically allows me to control, not to subscribe too much. Bottom line, if you need to audit changes, use entity hooks. Just one note, it only works for entities. It doesn't audit your queries. So it will only work if you making changes through the entities, because for queries, Exposed doesn't actually know how many lines would be touched by that query. So this will work only for entities. Next, let's talk about enums. Using a new framework is all great when you work on a greenfield project and get to define your own schema and populate the data from scratch. But that's not always the case. Let's imagine that in your Kotlin code, you have the following enum. And the comments represent what the actual values in the database are. So you have all the corresponding values. There's no issue with that. But someone may have made some spelling mistakes here. And if you think that never happens, let me remind you that we all live with a spelling mistake in the referrer HTTP header. In any case, you don't care about someone else's mistakes. You want your code to be better. So how do you do that? Well, first, let's recap how regular enums are defined. Here I define a column that will be represented as an enum in Kotlin code and as a varchar of length 20 in the database. The only problem is that if I was to use that definition, the values in the database would match the toString representation of the enum, and that's not what we want. So instead, we'll need to use a slightly more complex enum column definition, which is called custom enumeration. Instead of 3 parameters, the type of the enum, the name of the column, and its length, we now have 4. First parameter is the name of the column. Then the second parameter is its full database definition. Because with custom enums, there's no guarantee this column will be a varchar anymore. So you need to provide the full definition as it's defined in a database. It can be any column, anything your database supports, really. Then there are 2 functions called fromDB and toDB. Let's first take a look at the fromDB function. It receives the value that is stored in the database. Note that this value is of type any, so there are no guarantees that it's valid. You need to check it yourself. And then for each value, we assign the correct enum. Now, in this case, we don't know that we cover all the cases. Maybe there is some garbage data in your production database, and we only discover this when we crash at runtime. The toDB function is safer because it works with Kotlin enums. It takes an enum as an input, and then for each enum value, we need to define what's the value we'd like to write to the database. This is nice and easy. So custom enumeration is a powerful tool to work with legacy data, but it also removes some of the safety guarantees Exposed provides you. May be useful in some cases when you work with legacy data, but be careful because that fromDB function is not very safe. I think that's my final point for today. Now, I talked a lot about how the aim of the Exposed framework is to provide a type-safe and ergonomic way to work with databases. And I hope that I showed a few tricks how to do that efficiently. Maybe I even convinced some of you to give Exposed a try. But sometimes a database feature is too specific or too new for the Exposed framework to implement it. So there is an exec method available to you inside the transaction. And that method will execute an arbitrary prepared statement. This method exposes a low-level Java API, so you have an awkward iterator and indexes that start with 1. Not recommended, use only as your last option, but many people ask about that, so I felt that I need to include it as well. Well, let's quickly recap the things you may have not known. Exposed provides you with a flexible way to define many-to-many relationship using the via function. If you have a connection table, Exposed will fetch related entities through that table automatically. We discussed why Exposed requires you to pick the date library you work with, and that by default, you should pick Kotlin datetime. In Exposed, you can log a single query. No need to log all of them. There is a coroutine support, so if your code uses suspending functions, it's not a problem for Exposed. Use new suspended transaction as an adapter, and your suspending code will just work. If you need to use nulls in your query, there is a special expression for that built in. You don't need to look for workarounds. You also don't have to map SQL results to entities manually. Exposed can do that for you. If you need to audit what happens with your entities, there is entity hook that you can subscribe to. If you're dealing with legacy data, there is a custom enumeration column type that allows you to define exactly how your data is mapped when it's read and when it's written to the database. And finally, you can break Exposed and use arbitrary statements if you really have to. That's all the features I wanted to talk to you about today. If you have questions on how to use some of the Exposed features, me and other contributors will be happy to answer them on Stack Overflow or in the Kotlin Exposed Slack channel. If you find any bugs related to Exposed library, you can open a GitHub issue and the team will look into it. And if you have an idea for improving the library, pull requests are more than welcome. Thanks again for attending my talk. If you liked it, you can find me on LinkedIn, Medium, or Twitter. Also, please don't forget to vote. If you want to learn more about the Exposed framework, I recently released a course on it for LinkedIn Learning. It's an 1-hour course. It covers all the basics of the SQL DSL and some of the advanced topics as well. If you have LinkedIn Learning, you should check it out. Also, a couple of years ago, I created a course on system design that's available on Udemy. It's called Pragmatic System Design. If you're into software architecture, I have a coupon for you that will let access you it for free. So it's just KotlinConf 2023. And also, my book on Kotlin design patterns is available on Amazon, and I have somewhere a copy here. You'll find it later. And last thing I wanted to say, as someone who was born in Ukraine, thank you all for your support. Glory to Ukraine. Enjoy the rest of this great conference, and thank you.